Greetings dear viewers, I am Volodymyr Didur, third year bachelor student at the Department of Computer Science at Khmelnytskyi National University, and I present to you the research on detecting political manipulations techniques in internet posts, thresholds auto-selection in multi-class decision space. In modern society, information manipulation has become a widespread practice, covering various areas from politics to advertising, media and social networks. Due to this, in condition of information overload, manipulation is increasingly becoming a tool for influencing public opinion and people behavior. Development of artificial intelligence technologies has significantly accelerated the process of spreading manipulation, since now content can be generated not only by people but also by automated systems that are able to create texts that are almost indistinguishable from materials written by people. Manipulative content is becoming more difficult to detect and analyze. Therefore, along with the development of these technologies, there is a need to develop new artificial intelligence models capable of detecting such manipulation techniques in texts. The paper aims to increase the accuracy of political manipulation techniques classification in internet posts by optimizing threshold solutions. The main contributions are the development of method for neural network models fine-tuning by one versus rest strategy, which includes the thresholds auto-selection optimization in multi-class decision space. Method differs from the existing ones by the use of individual threshold values for each type of manipulation technique, which allows for a more accurate account of various semantic markers characteristic of each of the techniques. The use of one versus rest training strategy is proposed, which allows for the classification of manipulation techniques set into separate classes, taking into account specific characteristics of each of them. The related works review found that existing methods for classifying political techniques is internet posts have several significant limitations. One of the key shortcomings is the use of universal threshold values for all classes, which does not take into account the specifics of each manipulation technique. Most approaches use traditional multi-class classification strategies that do not provide adequate separation between classes with high level of feature overlap. Insufficient attention to the individual characteristics of manipulations techniques complicates the results of interpretation and reduces the model's practical effectiveness. And on this slide you can see the generalized diagram of man interacting with tracks of political manipulation techniques detecting. The result of running track 1 is finely tuned model set F, each of which is trained using one versus rest strategy for corresponding manipulative technique. The manipulative technique set T has a dimensional equal to the number of political manipulation techniques identified in research. You can see all the techniques to the right of the slide. The result of track 2 execution is the identified manipulation techniques in the internet posts. The political manipulation technique is considered used if the neural network value is above the threshold. The threshold is determined adaptively by each manipulative technique on track 1 using the Yoden criterion. On this slide you can see the method for neural network models fine-tuning by one versus rest strategy. On step 1, relevant fragments labeled as manipulative and are extracted from a dataset, processed and organized into separate categories for each manipulation type. On step 2, separate binary transformer based classifiers are trained for each manipulation technique using the one versus rest approach. On step 3, classification thresholds for each model are optimized to enhance performance. On step 4, the models are evaluated using standard metrics accuracy, precision, recall and F1 score. And at the output we have the set of binary fine-tuned models. The dataset used was developed during the 4th Ukrainian workshop on NLP, UNLP 2025, focused on identifying political manipulation in social media. It includes annotated text fragments labeled by the authors. The dataset includes a total of 3,822 unique documents. Out of those, 2,589 are labeled as showing signs of manipulation, while 1,233 are not. A single document can be labeled with more than one manipulation technique. They are not limited to just one. Most of the documents are in Ukrainian, but during analysis we also found some entries in other languages. On this slide you can see the original dataset distribution of documents and preprocessed version. On this slide you can see the process of distribution of text fragments into directories according to manipulation techniques. From the input dataset D containing the text fragments and their labels, fragments annotated by authors are expressed as manipulation techniques are extracted. Each fragment is placed in a separate file, which is placed in a directory with the same name as the name of the manipulative technique. If there are several techniques within the document, fragments are duplicated in directories with the same name for the techniques expressed. This slide outlines the construction of the dataset used to fine-tune each binary classifier. Positive samples are taken from the target catalog and represent texts that express specific manipulation technique. All of these are included in the positive class, with the total number equal to the number of available examples for the technique. Negative samples are formed from two sources. A portion consists of random texts without any manipulative content, and the other portion includes texts that contain manipulations but of different types than the target technique. The proportions of these two parts are controlled by the hyperparameters alpha and beta, which sum up to 1. The final training set for the model is the combination of both positive and negative samples, allowing the classifier to learn and to distinguish the target technique from all others and from non-manipulative technique content. This slide describes step 3 of the fine-tuning process, the threshold optimization for each manipulation technique. Each model calculates the probability that a given text belongs to a specific technique class. Based on that probability, the model decides whether to classify the text as containing that manipulation or not. The classification decision is made using a threshold. If the probability is above the threshold, the text is labeled as containing the manipulation, otherwise it's not. To get the best results, the threshold is chosen arbitrarily. It's optimized individually for each technique. This is done using the Yoden criterion, which helps to find the threshold value that best balances the true positive rate and false positive rate. This step is crucial for improving model accuracy and reducing false alarms. To research the proposed hypothesis about the feasibility of applying one versus rest learning strategy in combination with an adaptive threshold to each manipulative technique to increase accuracy, a series of experiments will be conducted with BERT-like dictations that support work with Ukrainian language, and the scheme of experiment is shown in this slide. The first part of the experiment involves training BERT and Roberta models. Python console app was developed for this, using PyTorch transformers and datasets libraries. It supports training with and without adaptive thresholds using one versus rest strategy. The app saves the trained models along with their evaluation metrics and the best threshold values. Also, as part of the second part of the study, a desktop application was created that uses the PySite, PyTorch transformers libraries and allows one to evaluate the quality of detected manipulation techniques. You can see the app in action in this screenshot. After training the classifiers using the one versus rest strategy, results were collected on both training data, 80% of the dataset, and test data, 20%. Those are shown in table. The data shows that Roberta generally performs better than BERT on the test set, especially in terms of precision and F1 score. This suggests Roberta is better at recognizing manipulative patterns and generalizing to new examples. While BERT performs strongly on the training data, it shows a noticeable drop in test performance for some techniques, like bandwagon, which may point to overfitting. In contrast, Roberta contains more stable performance across both training and test sets, especially for techniques like cherry picking, glittering generalities, and whataboutism. This balance highlights its better generalization ability. The results of evaluation of neural networks using one versus rest strategy with adaptive threshold is by transformation are shown in this table. Analysis of classification results using the BERT and Roberta models shows that the one versus rest strategy with an adaptive threshold improves accuracy over the baseline. Roberta generally outperforms BERT, particularly in stability between training and testing. The biggest difference is seen in the whataboutism and FYD techniques, where Roberta's F1 score and precision are significantly higher, indicating better differentiation and reduced overfitting compared to BERT. On this slide you can see the comparison of detecting political manipulation techniques by BERT and Roberta neural networks with and without threshold auto selection by precision metric. On this slide you can see the comparison of detecting political manipulation techniques by BERT and Roberta neural networks with and without threshold auto selection by recall metric. And on this slide you can see the comparison of detecting political manipulation techniques by BERT and Roberta neural networks with and without threshold auto-selection by F1 metric. Compared to known analogs, this approach allows to obtain high estimates. Comparison of the approaches with the proposed one is given in table you can see on the screen. 1 versus rest with the adaptive threshold improves classification accuracy, especially of one macro. Roberta outperforms BERT with better generalization and stability. Strong performance for whataboutism, FYUD, and Litrian generalities. Loaded language shows poor generalization due to data limitations of variability. Method is limited to Ukrainian, only 10 techniques, and text files up to 7,514 bytes. And to conclude, proposed method uses 1 versus rest strategy with automatic threshold selection to detect political manipulation in posts, fine-tuned BERT and Roberta models for Ukrainian language, thresholds optimized using the Yodin criterion, Roberta with 1 versus rest improved F1 macro from 0.725 to 0.73 with threshold optimization to 0.76. It's increased by 0.135 overall. Limitations: only 10 manipulation types studied, tested only on Ukrainian language, and future work will include expanding dataset, testing on multilingual data, and improve adaptability to complex techniques. Thank you for your attention.